Hi, welcome to lesson 7 of Simultaneous Equations. Today we are going to be looking at using elimination to solve real-life problems. First though, can you pause the video and have a go at these two starter questions, please? Okay, let's have a look at the solutions for these questions. So for A, we have 3x plus 5y equals 23 and 5x plus 2y equals 13. So these equations are set up for the elimination method. We need to decide whether to eliminate the a terms, in which case we'd need to multiply by 5 and 3, or eliminate the y terms, in which case we'd need to multiply by 5 and 2. That's slightly easier, so we're going to use 5 and 2. Remember, one of the values needs to be negative so that we can get opposite signs. So equation 1 will become minus 6x minus 10y equals negative 46. Equation 2 becomes 25x plus 10y equals 65. Remember, every single term is multiplied by the value. Now we can eliminate. So we add the two equations together to eliminate the y terms. This will give us 19x equals 19. So therefore x equals 1. We substitute that into one of the original equations. So I've chosen equation 2. So this will become 5 plus 2y equals 13. So we take the 5 over and subtract, so 2y is 8. Therefore y must equal 4. So our solution is 1, 4. For question B, we need to decide whether to eliminate the y's or whether to eliminate the x terms. To eliminate y, we need to multiply by 2 and 5. To eliminate the x terms, we need to multiply by 3 and 2. That's slightly easier, so we're going to go for the x terms with 3 and 2. Again, one of the values needs to be negative so that we can get our opposite signs. So equation 1 becomes minus 4y plus 6x equals 22. And equation 2 becomes 15y minus 6x equals negative 33. Now we can eliminate the x terms by adding the two equations together. So we get 11y equals negative 11, so therefore y must equal negative 1. We're going to substitute this into equation 1 this time. So that will become negative 2 subtract 3x equals negative 11. Take the minus 2 over, so we end up with negative 3x equals negative 9. Divide by negative 3, so we get x equals positive 3 this time, so our solution would be 3, negative 1. Today we are looking at solving real-life problems using elimination, and by the end of the period we should be able to construct an equation to represent the real-life situation and apply the elimination method to solve these real-life problems. So let's have a look. So when we use simultaneous equations to solve real-life problems, it's called algebraic modelling. Let's have a look at an example. So here we have, for a concert, 1 adult ticket and 3 child tickets costs £150, and 2 adult tickets and 5 child tickets costs £270, and we are being asked to find the cost of each kind of ticket. The first thing we have to do is choose a letter to represent each item. So we just take the common sense approach and use A for the cost of an adult ticket and C for the cost of a child ticket, unless the question specifically asks you to use particular letters. Often that would just be X and Y. So let's look at creating the equations. So 1 adult and 3 children costs £150, so we would just write this as A plus 3C equals 150. 2 adults and 5 children cost £270, so we would write that as 2A plus 5C equals 270. After that, we just apply the elimination method to solve the problem. So let's look at example 1 in full. So we're using A for the cost of an adult ticket and C for the cost of a child ticket, and our equations will become A plus 3C equals 150 and 2A plus 5C equals 270. We need to decide which term to eliminate, A or C. So if we look at the A terms, we just need to multiply by 2. If we want to eliminate the C terms, we would need to multiply by 3 and 5, so the A terms are easier. So in order to do that, we just need to multiply actually by -2, because remember, one value must be negative so that we have opposite signs. So if we do this, equation 1 will become -2A minus 6C equals -300, and equation 2 stays the same. Now we can add the two equations together to eliminate the A terms, and we are left with -C equals -30. So if we divide by -1, we get C equals 30. Now to find the value for A, so substitute C equals 30 into equation 1. This becomes A equals 150, subtract 90, so A equals 60. So in terms of the question, that would mean a child ticket costs £30 and an adult ticket costs £60. Let's look at a second example just to make sure we're understanding this. So here we have 2 teas and 3 coffees cost £10.50 and 5 teas and 2 coffees cost £13.60. We want to find the cost of a tea and the cost of a coffee. So, common sense approach, we use T for the cost of a tea and C for the cost of a coffee, which means our equations will become 2T plus 3C equals 10.50 and 5T plus 2C equals 13.60. We need to decide which term to eliminate. If we want to eliminate the T's, then we need to multiply by 2 and 5. But if we want to eliminate the C terms, we need to multiply by 2 and 3, which is slightly easier, so we'll go for that. Remember, one of the values needs to be negative so that we get our opposite signs. So equation 1 will become -4t subtract 6c equals -21, and equation 2 will become 15t add 6c equals 40.80. Now we can eliminate C terms by adding the two equations together. So we end up with 11t equals 19.80, so t would be 1.8. Now to find the value of C, so substitute 1.8 into one of the original equations and we get 3c equals 10.50 subtract 3.60. So 3c equals 6.90 and we divide to get c equals 2.30. In terms of the question, that means the cost of a tea is £1.80 and the cost of a coffee is £2.30. Okay, now your turn to have a wee go at some questions. Okay, so same as always, go to poster files on the team and get today's exercise and answers. Do your work into your class jotter. Make sure you show all your work in and mark and correct your work at the end, please. Thank you.